is lecture number 20 for the chapter application derivative for the class 12th, and we're discussing the miscellaneous exercise. Let us take the question number 13, and the function is given fx equal to x minus 2 raised to power 4 x plus 1 whole cube for all x belongs to real numbers, and you have to find in which interval it is increasing and decreasing. To find the derivative of this by using the product rule, first of all differentiate x raised to power minus 2 raised to power 4, which is 4x minus 2 ka whole cube x plus 1 whole cube. Then differentiate this. You know how to find the derivative. You can take x minus 2 raised to power 3 common and 1 plus x plus 1 raised to power 2 common in this, and on taking common, these are the factors, which is x minus 2 whole square, x plus 1 whole square, 7x minus 2, and put it equal to 0 as you know it. To find which interval the function is increasing and decreasing, the value of x is coming out to be 2, minus 1 and 2 upon 7. So first of all, at x is equal to 2, we are using the first derivative test to find it is increasing or decreasing, or we have the maximum minimum value of this function. Now at x equal to 2, take the value of x slightly less than 2. Now when you take the value of slightly less than 2, then the first derivative will be negative because this will be positive, this will be positive. When you take the value of x as slightly less than 2, then this term will comes out to be negative. Now when we take the value of x slightly more than 2, then this will be positive, this will be positive, and this comes out to be positive. So the first derivative is coming out to be changing from negative to positive. When the first derivative changes from negative to positive, then we have local minima at the given point, which is equal to 2. So the local maximum value will be f2 by putting x as 2 in the original function, which is coming out to be 0. Now we'll show that at x is equal to minus 1. Now take the value of x slightly less than minus 1 and then take the value of slightly more than minus 1. Then when you take the value of x slightly less than minus 1, then this less than minus 1, positive, positive, less than minus 1, then this comes out to be positive. And when you take the value of x slightly more than 1, then the first derivative will be positive. Then because there is no change in the sign, that is positive to positive, then we have no maxima, no minima for this function at x equal to minus 1, that at x equal to minus 1 it have point of inflection. Now at x equal to 2 upon 3, when you take the value of x slightly less than 2 upon 7, then slightly less than 2 upon 7, then this first derivative will be positive. And when the value of x slightly more than 2 upon 7, then its first derivative is negative. And because its first derivative changing from positive to negative, then we have the local maxima at x equal to 2 upon 7. When the sign of first derivative changes from positive to negative, then we have local maxima. And the local maximum value will be obtained by putting the value of x is equal to 2 upon 7 in the original function, which is x minus 2 raised to power 4 x plus 1 whole cube. So in this question we have done how to find the maximum minima by using the first derivative test. First derivative test. Now in question number 14, again you have to find the maximum minimum value of the given function, which is fx is equal to we have cos square x plus sin x, and x belongs to 0 to pi. So as usual, find its first derivative, which is minus 2 cos x sin x plus cos x, put equal to 0. Simplify this, you are taking x cos x common, which is 2 sin x minus 1, put it equal to 0. Cos x is equal to 0 and sin x is equal to half, and cos x will be 0 when the value of cos x will be 0 when the x is the multiple of 90, odd multiple of 90. And why I have taken this 90? Because it's lying in this quadrant. Now sin x will be half when it is in the first and the second quadrant. So in the first quadrant it is 30, and in the second quadrant will be 180 minus 30, that is 155 pi by 6. So this is the angle for which it can have a maxima or minima, and because it will have the closed interval, so we can find the maximum minimum value without calculating its second derivative. So the points we can take as 0, pi by 2, pi by 6, 5 pi by 6 to find f0, f pi by 6, f pi by 2, f pi by 6, and f pi. All these value of function for these angles, pi by 2, pi by 6, 5 pi by 6, 0 and pi. When we have the closed interval, we can find the maximum, exact absolute maximum and absolute minima. So when you put x equal to 0 in the given interval, you're getting 0. When you put x equal to pi, you're getting the value of this function as 1. When you're putting the value of x equal to pi by 2, you're getting the value of this function as 1. When you put x equal to pi by 6, the value of cos square pi by 6 is root 3 by 2, and sine pi by 6 is half, it is 5 by 4, and at 5 pi by 6, which is 150 degree angle, cos 5 pi by 6 will be root 3 by 2 minus root 3 by 2, and sine pi by 6 will be half, 5 upon 4, 5 upon 4. So maximum value is, absolute maxima is 5 upon 4 at these two angles, and the absolute minima is 1 at these three angles. So this is the question number 14. Now in question number 15, it is this type of question we have already done in the last exercise. It is given that there is a cone is inscribed in a sphere of radius small r. Radius is small r, it is given, and we have let that the radius of the cone be capital R. So height of the cone be capital H, from AB is equal to capital H, height. So OB will be equal to AB minus OA. So AB is H and OA is equal to R. This is the OB. Now we have to show that its volume of the cone is maximum. You have to show, and the height, you have to show that the height of the cone is 4 upon 3, the radius of the sphere you have to show. So find the relationship between small r and r by using the Pythagoras theorem in the triangle OBC, which is r square is equal to h minus r ka whole square plus r square, because OB is h minus r, we have already find it out. So this is the relationship between capital R, capital H, and the radius of the sphere, and we have to find the radius, the value of capital R from this relationship. So the volume of the cone is 1 upon 3 pi r square h. Replace the value of r square as 2hr minus h square, and simplify and differentiate with respect to h, because the small r is constant here and only the variable thing is h, the height of the cone. So differentiate with respect to h, it will be 2h and it will be 3h square. So it is coming out to 4 upon 3 pi hr minus pi h square, put it equal to 0. It will be 4 upon 3 pi hr is equal to pi h square. 1 h will be cancelled out, pi will be cancelled out. So h is coming out to 4 upon 3 r, that is the height of the cone is 4 upon 3, the height of the 4 upon 3, the radius of this sphere. Now find the second derivative, which will be 4 upon 3 pi r minus 2 pi h. It will be negative when you put h is equal to 4 upon 3 r. It will be negative. So its volume is maximum when height of this cone is 4 upon 3, the radius of the sphere. Now in question number 17, a cylinder is inscribed in a sphere of radius capital R, and you have to show that its volume is maximum when it is given, when height of this cylinder is 2 upon root 3, the radius of the sphere. So let the radius of the cylinder be small r and the height of the cylinder be h, and when it is inscribed in a sphere, then the diameter of the sphere will be this, that is from this point to this point, h is this, and this will be 2r, small 2r. We have let that the radius of the cylinder be small r. So using the Pythagoras theorem, that is 2r whole square is equal to h square plus 2r whole square, and this is the relationship between capital R, small r, and height of the cylinder, and you have to prove that the volume of the cylinder, which is pi r square h, is maximum. So I have eliminated this r square, and the r square will be equal to 4r square minus h square upon 4, because there are two variables and you have to always eliminate one variable. We have discussed then in maximum minima word problem. So differentiate with respect to h because capital R is constant here. So differentiate with respect to h, it will be pi r square and it will be 3h square. Put it equal to 0 and you are getting the value of h as 2 upon root 3 into r. Pi se pi cancel and multiply by 4 upon 3, h will be 2 upon root 3 r. When you find the second derivative, it will be pi r square minus differentiate with respect to h, its second derivative. This will be 0, this will be 3 upon 2 pi h which will be negative when h is equal to 2 upon root 3 into r. So because the second derivative is negative for volume, second derivative of the volume is negative, so it means volume is maximum when h is equal to 2 upon root 3. So this is the question number 17 of this miscellaneous exercise. It is somewhat easy question. Now after this we have question number 18, which is somewhat lengthy question and is the lengthiest question of this chapter. Now see it very carefully. There is a cylinder which is inscribed in a cone and you have to show that the height of the cylinder is 1/3 the height of the cone, which is given equal to h. Small h is it is given. And you have to show that the volume of this cylinder is maximum when the height of this cone is 1/3 the height of the cone. Okay, we'll discuss this in the next lecture and the remaining question also. Thank you.